Okay, welcome to the second part of the email theory that we are doing, and here's the second part of the topic led in relative mathematics. And I hope you have watched the first part, which is the introduction of the head, and the part 2 is the addition of head, and I told you in the first part 1. Now, addition of head. Now, third, as you already know, is a value that is having something like, let's say, a root of b. So if I'm having a root of b and I'm having another third, let's say b root of, let's say, d. If that is the case, then I can do some mathematical operation, whether I can add, subtract, divide, or multiply. Right here we are going to tackle addition and subtraction of head. Now, addition and subtraction of head obey a simple algebra rule in which like terms can be only subtracted or added. So I can have, let's say, a root b plus, let's say, c root b. Here I can call these two to be like. Why? This is root b and here is root b. If that is the case, then the only thing that I need is to just add the coefficients, the c and the a, to have a plus c or root of b. I will just add a and c together, and I will just take one of the b and multiply it to it. This one is something like I factorize the b out. So when I add this and bring the root of b, I'm done with it. I hope it makes sense. Now, let's try to use this to work some examples and see. Let's work some examples and see how it will be going by. Let's say I'm having root, let's say 2 plus 3 root 2. For this one, how can I add these two? The rule is saying that when I check from here, it's saying that I should take the coefficient to just add them. Now, this one is just saying, so the coefficient of this one becomes 1, but we don't write it. Sorry. The coefficient of root 2 becomes 1. So we'll be having 1 plus 3, like this, 1 plus 3, and all of these, and I will take one of the root 2, and I will be just having this. So it will be just let's say 4 root 2 to be the final answer. 4 root 2 to be the final answer. I'm sorry for my handwriting, like my camera is disturbing me. Well, okay, let's try to look at another example. Let's try to look at another example and see how we can tackle it. Let's say I'm having root 72. I'm having 72 plus root of 18 plus, let's say, root of let's say 81. Let me just take that. Now, to just do this, it is very simple. Just simplify each of the root 72 into a simpler third form then you simplify root 18 to a simplified form, and this 81, I think it is a full a perfect square. For that, it is very easy. Now for the 72, how can I convert that into a simple one? I find two numbers in which one factors of this, in which one of them is a perfect square and one of them is not a perfect square. So for that 72, I'll get 38 times 2. 38 times 2 will give me 72. Plus the 18, I'll get what? For the 18, I'm going to get 9 times 2. That is going to give me 18. 9 times 2. And for the 81, it is just going to be 9, because the root of 81 is 9. So for this one, root of 38 is going to be 6. So I will get 6 root 2. This is more explained in the part 1, so you can check that one and let's move on. And for this one, it is 3 root 2 plus 9. This 9 here is not a set variable, it's just a mere number. You know how to tackle with that. Now, I'm having root 2, cake root 2, and 3 root 2. Since the numbers over here are the same, then I can choose to add the coefficient, which is 8 plus 3, which will make it 9 root 2 plus 9. So this becomes the final answer for 72 plus 18 and those 81. Like it. Okay, let's tackle another example. That is example 3. Go for the example 3. Let's look at root of 50 plus root of 32 minus root of 152. For this one, how can I go by it? Root 50 is just going to be root of 25 times 2, because 25 times 2, that you are going to get 50, and 25 is a perfect square, plus 32 is going to be 15 times 2, and 15 is a perfect square, so I can get that, minus 152. 152 is going to be 81 times 2. 81 times 2 is where you are going to get 152. Go for the root of 25 times 2 is going to be just 5 root 2 plus root of 15 is just going to be 4 root 2 minus root of 81 is 9 root 2. Go for the here is root 2 root 2 root 2. Hence I can simplify to have 5 plus 4, because here the operation between them is plus, and here too it is minus 9. Just the coefficient is what I'm just using the mathematical operation on. All root 2 like this. Go for that. For that 5 plus 4 is 9 minus 9. That is going to be 0. So it is going to be 0 root 2. And this 0 over here is something like 0 times root 2, and therefore you make the final answer to be 0. Very interesting. Just working a lot of these mathematics and you get the answer to be 0. That shows that mathematics is somehow funny. Okay, so that's it. We are having root of 50 plus root of 132 minus root of 152. We first break this into 2, in which one of the factors need to be perfect square, and hence we had 25 times root 2 plus, and for the 15 to equate them to have 15 times 2, which 15 is a perfect square, minus 152, we split it into 2 to have 81 times 2, and here too, the root of 25 becomes 5 root 2 as this one, because root of 25 is 5, so it will be from under the root because we have first taken the root of, plus root of 15 times 2 is just 4 times root 2, 4 root 2, and root of 81 times 2 is 9 root 2. Now the law is saying that we need to just add the coefficient. We need to manipulate the coefficient only. So for that I'm having 4 plus 5 plus 4 minus 9, and I'm having over here 5 plus 4 minus 9 to be 0, and hence I'm having the final answer to be 0 like that. Now let's try to tackle another example and see how this is going. Let's tackle another example and see how this is going. So for this, let's do this one and see how it will feel. Like let's root of 80 plus root of 20 minus root of 45. Root of 80 plus root of 20 minus root of 45. For this, let's try to split them. For 80, it is going to be 15 times 5. Is where we are going to get 80, in which 1 is a perfect square and 1 is not. Plus root of 20 is 4 times 5, in which 4 is a perfect square and 5 is not. So we qualify, and 4 times 5 will give you 20. Minus root of 9 times 5, in which 9 times 5 will give you 45. 9 is a perfect square and 5 is not a perfect square. So for here I will have 4 root of 5, that is root of 15 will give you 4, plus 2 root of 5 minus 3 root of 5. Here is root 5, root 5, root 5. So hence I'm going to have that is just 4 plus 2 minus 3, or root 5, and 4 plus 2 is minus 3 will be 3, so I will be having 3 root 5 as the final answer. 3 root 5 as the final answer. So very simple, very simple. Let's try the last one out and see how it is going to be. Let's try the last one out and see. Now for that I'll be having root of 50 as the above, plus root of 32 plus root of 80 minus root of 45. Let's see how this is going to be. So for this one, root of 50, as we did it earlier, we'll be having 5 root 2. We'll be having 5 root 2, and root of 32 will be 4 root 2, plus root of 80 will be 4 root 5, minus root of 45 is going to be 3 root 5. So for this, you can see that it has been grouped into 2. All these is root 2, and here 2 is root 5. So these are like, and also these 2 are also like. So I can do this and do this separately to have here 5 plus 4 will be 9. So I'll be having 9 root 2, and the operation over here is plus, and here 2 will be 4 minus 3, which is 1 root 5. But here we don't write the 1 over there. So I'm having the final answer to be this. You can add these together because here is root 2 and here is root 5. I think it makes sense. Okay, so for that note, go ahead, practice more examples. If you have any question, leave it in the comment section below and wait for the part 3, which is going to be the multiplication and the division of third. Multiplication and the division of third. Very simple. Wait for part 2. Please subscribe to help the channel grow. Subscribe so that I can get motivated and bring you more videos. Wait for physics, chemistry, and also the core mathematics. And for your information, from next time, every day I'll try my best to solve one word problem question. So it seems that people are very annoyed about word problem, but it seems to be very easy. Every day I'll try my best to solve one word problem question so that you'll be knowing how to tackle these things easily. Goodbye. Subscribe for more. Thank you.